Okay, mayong hapon. Welcome to the class. This is Chem 102. Chem 102 is organic chemistry. This afternoon, our topic is about electronegativity and bonding. So we'll give you a brief background what is electronegativity and bonding. And today is March 4, 2021. So, electronegativity is conceived to be the ability of atoms involved in a chemical bond to polarize electron, meaning attract electron density towards itself. Okay, so there are various scales, which is for our example, we're going to use Pauling scale. No? This is the most common scale used by chemists, okay, to describe electronegativity of a certain atom. Okay, and it's still most widely used. Yes, that's correct, no? And Pauling originally based its scales on the ionization energies and electron affinities. Another book, okay, describe also electronegativity, which is symbolized En, is a measure of atoms' tendency to attract bonding pairs of electron. So meaning the stronger electronegativity or has the stronger En, an atom that has a stronger En will steal an electron, okay, towards another atom. Okay, in general rule, the En or electronegativity values of an element tends to increase, no, because it's stealing from the other one, no? As you move from the left right regardless, no? And which well, we have an exception of a noble gas, which we do not have En values. Okay, so noble gas in a periodic table of elements has no En values in the Pauling scale. Okay, Pauling scale. Okay, so here's the Pauling scale. Okay, so the labeled red are the En or the electronegativity of a certain atom. Okay, so we have common atoms, where is carbon. Carbon is 2.5. We have hydrogen is 2.1. Oxygen is 3.5. Okay, so a lot. Okay, so this is presented here, and I'll be we have an example, okay, for this. So for example, the most common one that we've discussed, for example, we have carbon. Okay, so I have carbon here, and then I have oxygen here. Okay, so as we know that oxygen has four valence electron, okay, because this belong to group 4, and oxygen has how many? 5. Okay, so I have a dot here. Okay, and this is 5. Okay, so suppose this is the covalent bond between atoms, between those two atoms. Okay, I'll label is blue. Okay, so okay, this is the representation of a covalent bonding between carbon and oxygen. Okay, so if we go back in our table, the Pauling scale, we know that here is the carbon 2.5, and oxygen has how many? 3.5. So carbon is 2.5. Okay, this is 2.5. Okay, this is 2.5. Okay, and versus 3.5. Okay, this is 3.5. Okay, so uh, as we inspect oxygen, okay, oxygen, the difference of 1, okay, the difference of 1, oxygen has the highest En or electronegativity. So in this case, oxygen steals, okay, a loose electron from carbon. Okay, so because its highest En 3.1 versus 2.5, oxygen is stronger, no? Okay, so there's still a covalent bonding, but the electron from carbon tends to move, okay, to move to oxygen. Okay, so we call this as polarized covalent bonding. Okay, so polarized covalent covalent. Okay, this is bond. Okay, this is bond. Okay, okay, so polarized covalent bond. And This is represented by a Greek word alpha here, and uh, a Greek word, okay, so alpha here, okay. So here, since it's losing electron, it's polarized, and then this is gaining electron. So that negative representation is an indication that oxygen through this bonding is stealing electron from the carbon atoms. Okay, so that is one example, and we have another example. What if we have two carbon here? Okay, so carbon, I have two carbon here, and there's bonded. Okay, that two valence electron bonded. Okay, so as we know that carbon is four valence electron, belong to group 4. Okay, so we will represent this by a blue, okay, because this is the covalent bonding. Okay, so as we know that carbon has 2.5 En, okay, or electronegativity. Okay, 2.5 En. By the way, electronegativity has uh, no unit. Okay, this is a unitless. Okay, so unlike okay, so 2.5, and if we are going to take the difference, as you see, this is 0. Okay, so 0. Okay, so carbon A or carbon 1, carbon 3, nor or either, okay, steals covalent bond from each other, because both carbons have same En 2.5. So for this instance, we call this as non-polarized, non-polar covalent bond, or non-polarized covalent bond. So this is an example of non, okay, polarized or polar. Okay, so I'll abbreviate the covalent bond into CB. Okay, okay. So this is what we call non-polar covalent bonding. Okay, so we have another example here. Okay, so another example is what if we have a carbon. Okay, carbon. Okay, so I'm using the black. I have a carbon and carbon atom with sample is hydrogen. Okay, so as we know that carbon has 4 valence electron, and then they form a covalent bonding with hydrogen. Okay, so by looking at the Pauling scale, okay, here, okay, so hydrogen has 2.1, hydrogen is 2.1, and if we're going to go back, okay, so this carbon is 2.5, okay, versus 2.1, okay, 2.1, and the difference is how many? Difference is 0.4, okay, 0.4, okay, so 0.4. So okay, so this scenario, since a lot of books, no, say that as long as it's not greater than 0.5, okay, it can still be considered as non-polar, okay, polar covalent bonding. Okay, so we have 3 examples using Pauling scale. Okay, so that is what we call electronegativity, no, by simply saying electronegativity, the higher En uh, in that molecules, meaning two atoms holding together through bonding, the highest En has the ability to steal, steal meaning kawat, steal electron towards the weaker. I'm not weaker, no, the an atom that has less En or electronegativity, no, in that bonding. So that is the short explanation for electronegativity and bonding, and I'll be giving an example, and then I think I'm asking I'm asking you to perform, okay, to evaluate two compounds, okay, and I'll let you distinguish if it is a nonpolar or polarized covalent band. Of course, no, we're going also to establish how many AN per atom, okay, as we've presented in our discussions for today. Again, we have no synchronous class for today, and I'm asking you to visit the link or uh, watch this as in our pre-recorded video, and for you to answer your homework. I think we're on homework number 5.